Hello and welcome to this section of the MATLAB tutor. In this section what we're going to do is talk about the trigonometric functions and also their inverses. And it's very similar to any typical calculator that you've used before. So it won't be a big deal for you to figure this out and understand it, but we do need to go through it because you'll be using sine, cosine, tangent constantly when you work with MATLAB. The easiest thing is just to show you how to take the sine of something, because everything else follows from that and they're pretty easy to understand. So you see we started typing that in and MATLAB starts trying to help us with the function. So it's literally the trig functions, you just type them in just like you would on a calculator. So for instance, sine of 10, you have to close the parentheses off. Sine of 10 is going to return negative 0.54. Now, the thing you need to make sure you understand is that any sine, cosine, tangent, trig function in MATLAB is going to be interpreted in terms of radians. So this is not sine of 10 degrees it just did here. This is sine of 10 radians. So that's very important for you to remember, and that's usually the standard mode in most calculators too. So to take the cosine of something, 20 radians, you would just do it like that. Tangent. And also, not only is sine, cosine, and tangent built into MATLAB, but you have the secant function, do secant or something. Now that we've done secant, we can talk about cotangent. That would be the cotangent function, like this. And finally, we have cosecant. Cosecant looks like CSC, like this. Now, when I learned the trig functions, these were exactly the way that we learned how to spell them. Sine, cosine, tangent, secant, cosecant, cotangent. So basically you're typing them in exactly as you would expect based on their name. So take a look at these and make sure you understand that. Let me clear the screen and kind of help you along with a couple other things here. So as I mentioned, sine of, let's do something that we understand, sine of 30. When you input it into MATLAB, it's going to always interpret it in terms of radians. Now sometimes you would like to input an angle in degrees. Now what we have here is sine of 30. Now if we don't do anything at all, MATLAB is going to interpret this as 30 radians. If you would like to have MATLAB interpret this as 30 degrees, all you need to do is on the inside take the 30 and multiply by pi over 180. And if you've never seen this before, it's worth pointing out because it's very useful and you can use this a lot of times even outside of the MATLAB environment. What you have here is a conversion factor. If you think about the unit circle, pi radians is, if you kind of visualize the coordinate axis in the unit circle here, pi radians is way over on the other side over here, right at 180 degrees. It's right on the other side of the plane, right? So pi radians is equal to 180 degrees. So when you write it as a conversion factor, pi over 180, what's happening is if you want the 30 to be in degrees, then the 180 is in degrees, and those are going to cancel, leaving you with radians. So what you've done here is you've basically set up a little conversion factor inside of your sine, and you said, all right, I'm going to take my 30, I'm going to multiply by pi over 180, degrees cancels with degrees, and then it turns the whole thing into radians. So this is sort of a cheap way of taking any number you want and converting it to radians by multiplying by this conversion factor. So if you wanted to do it this way, then MATLAB's going to return 0.5 because sine of 30 degrees is 0.5. You recall that. If you wanted sine of 60 degrees, you would just do 60 times pi over 180, and that would return 0.866, and so on. So you could just kind of keep going through there. If you really wanted to work in degrees, it's very easy to work in degrees. You just need to know the little trick of multiplying by the little conversion factor in here, which basically takes the number that you're trying to type in degrees and can't, since you're doing pi over 180, it basically converts it to radian measure. And of course this works with all of them. Cosine of 60 degrees, I would do 60 times pi over 180. And cosine of 60 is also 1/2. All right. Now let me just kind of go down here and just show you a couple of gotchas. These are things that you probably already know, but just so you know, if you wanted to do the tangent of something like 90 degrees, right? Pi over 180 like this, that would be converting to 90 degrees. So that's tangent of 90 degrees. You're going to get in some cases very large numbers. So this is 1.6 times 10 to the 16. You might say, what's going on here? But then if you think about it, if you go look at the tangent function, you'll see that there's asymptotes that go off to infinity at certain points. One of them is 90 degrees. So if you ever get a really large number that's just an asymptote in the graph, you see these guys especially with the tangent function. All right, let me go ahead and clear the screen here. So we've covered sine, cosine, tangent, cotangent, secant, and cosecant. We've learned how to input radian measures in there and get answers back. And we've learned how to also convert and basically use degrees and make MATLAB interpret it in terms of degrees also. Now the inverse trig functions are very easy to remember because for sine, for instance, it's a sine, arc sine in other words. So if you wanted to do the arc sine, you could type anything you want in here and MATLAB will return something. Now it's important to remember that whenever you type something into an inverse sine or an inverse cosine, the angle that you get back is going to be in radians. So this is in radians here. This is not 0.20 degrees. This is 0.2014 radians, right? So it will be a cosine for arc cosine, right? And you could go a tangent. And for cotangent, it would be like this. And then for secant, it would be arc, well, in this case, the arc secant of 0.5 is a complex number, so we're kind of getting a little bit of ahead of ourselves, but you can see that that MATLAB does understand complex numbers. Let me go ahead and clear the screen. We'll go ahead and do one more arc secant. Let's do inverse arc secant of, or I should say arc secant of 2. Here we have 1.0472 radians, and arc cosecant, again, of whatever, 7. And that's going to give us a number back as well. So at the core of this lesson, basically you know how to do sine, cosine, tangent, cotangent, secant, cosecant. You know how to do those guys in radian mode, in degree mode. You know how to do the inverse, or I should say the arc sine, arc cosine, all the inverse trigonometric functions. One thing let me show you here real quick. If you wanted to do the arc sine of, let's do 0.5 like we've already talked about here. What you're going to get back is something in radian measure, right? But if you take this guy and again multiply by a conversion factor, in this case 180 over pi, then what you're going to get back is 30. So this is again a cheap way of working in degrees if you really want to. In other words, if you'd like to take the inverse sine of 0.5, normally what you're going to get back is 0.5236 radians. But if you don't want radians, if you want degrees, then all you have to do is take this answer and multiply by the conversion factor, but this time it's flipped over. Instead of pi over 180, it's 180 over pi, because what you have is radians here. See, this returns radians. Okay, so when you multiply by 180 over pi, radians cancels with radians on the bottom and it leaves you with degrees. So this is sort of a very useful thing. Sometimes you multiply by pi over 180, like in the previous time, and here we're multiplying by 180 over pi. You arrange it in such a way to cancel the units, and so you're left with, in this case, we're left with degrees. So if you wanted to do the inverse or the arc cosine of, let's say 1, then you can multiply by 180 over pi, and so you'll get an answer back, and also in degrees. All right. If it wasn't quite so easy, if it was 0.6, then this answer would be in degrees, 53.13 degrees. So make sure you understand that, because sometimes you want to work in radian mode, and that's fine. Sometimes you want to work in degrees. Okay, now let me show you one more thing before we close this section off. We've already talked about how you can do the sine of, let's say, 30 degrees. It's easier for me to think in terms of degrees, so let me go ahead and do pi over 180 in here. So what I'm doing is I'm forcing it to work in degrees by multiplying by the conversion factor. We know that that's 0.5. All right. We also know from our basic trigonometry that sine of 60 degrees should be the square root of 3 over 2. But MATLAB is always going to return a decimal value. So this is the square root of 3 over 2. Sine of 60 is the square root of 3 over 2, but MATLAB returns as decimal. If you have the symbolic math toolbox installed, which if you're a student you already do, then what you can do is sometimes you can wrap the symbol command, 60 times pi over 180, like this. This symbol command basically tells MATLAB, all right, go ahead and evaluate the sine of 60 degrees, but do your best to keep the answer exact instead of just giving me a decimal. Let's see if MATLAB's smart enough. And you let it think for a second. 3 to the 1/2 divided by 2. And if you're really unsure what that looks like, you can do pretty. You can change the answer to pretty mode. And what you have is 3 to the 1/2 over 2. That's square root of 3 over 2. So I'm not going to give a bunch of examples with this, but I'm just kind of showing you the power of the symbol command. It doesn't always work, but certainly with the basic trig, parts of the unit circle that are just fundamental, MATLAB does understand that you can do that. Now, you can do cosine. Let's do cosine of 45 degrees. Anybody remember what the cosine of 45 is? Well, in exact terms, it's square root of 2 over 2. So here I've got cosine of 45 degrees because I'm doing a conversion to force it to work in degrees. And it says square root of 2 over 2. And just to visualize it better, there's square root of 2 over 2. So MATLAB does understand basic trig. It does understand exact values when you have the symbolic math toolbox. Most of the time you're going to be working in decimals, especially if you're doing simulations or something like that. But I did want to go in to show you how you can use the symbol command to try to get more exact answers out of MATLAB. So go ahead and pull out your copy of MATLAB, play around with the trig functions, make sure that you understand how to work in degree mode and radian mode if you so choose, and also make sure you understand how to do the arc sine, arc cosine functions, and so on. You just put an A in front of whatever it is, whatever trig function you're dealing with, to get the trigonometric inverses.